Hello, we're still working on quadratic equations and applications. We saw two methods before, which is factoring and extracting the square roots. Now we are going to see another method, which is completing the square. Okay, first I'll give you the general formula. So completing the square for the expression x squared plus bx, add b over 2 squared, which is the square of half the coefficient of x. Consequently, you'll have x squared plus bx plus b over 2 the whole squared will equal to x plus b over 2 the whole squared. Let's have some examples on this. Let's say I have x squared plus 10x plus 21 equals to 0. So first you have to make this b over 2 the whole squared stuff, which is 10, check it, divide it by 2, then square it. 10 divided by 2 will be 5, 5 squared will give you 25. So now we'll do x squared plus 10x plus 21, this 25, add it and subtract it. That means plus 25 minus 25 equals to 0. Now to make this one a perfect square, bring the 25 inside and take this constant number out, which means x squared plus 10x plus 25 in one bracket, and here minus 25 plus 21 equals to 0. I'll simplify this one. Minus 25 plus 21 will give you minus 4 equals to 0. Now this is a perfect square, which is x plus 5 the whole squared, and this is negative 4, it can be negative 2 the whole squared. Now you can see that this is a difference between two squares. You have a difference between two squares. That means you can do x plus 5 plus 2, and here you can have x plus 5 minus 2 equals to 0. Of course this will be an either or. Here it will be x plus 7 equals to 0, or x plus 3 equals to 0. In this case x will be negative 7 when you take it back, and in this case x will be negative 3. Okay, good. I'll revise for you the steps one more time. This was the question. So you took b and divide it by 2 and square it, you'll find 25. Now this 25, add it and subtract it on the original question. Take the added one inside, and from the question the constant take it out, which will give you here x squared plus 10x plus 25 minus 25 plus this 21. Now I would group them. This minus 25 plus 21 will give you negative 4, and when you change it to perfect square, this will be x plus 5 the whole squared minus 2 squared, and this is going to be a difference between two squares, which is x plus 5 plus 2 or x plus 5 minus 2. Then you can use your either or method once this will equal to 0 and once the other one will be equal to 0, and the final answer will be either x is negative 7 or negative 3. Okay, let's have another example now. Okay, here it says that you have x squared plus 2x minus 6 equals to 0. Now again you'll do the same thing. Take b, divide it by 2, then square it. B is here 2, so 2 divided by 2 the whole squared will give you 2 divided by 2 is 1. 1 squared will give you back again 1. So now x squared plus 2x minus 6 plus 1 minus 1 would be what? It will give you 0. And I'll do the same step like before. I'll bring the positive 1 inside and take the constant out. Here you'll have this grouping x squared plus 2x plus 1, and here you'll have minus 6 minus 1 equals to what? 0. Collect the like terms. This means when you add this you'll have negative 7 equals to what? 0. This is a perfect square, so I can change it to perfect square as x plus 1 the whole squared minus 7 equals to 0. To make it this difference between two squares, I need a square here, but you cannot change anything just like this. So you can add a root here so that you didn't change anything on this 7, because here this square will cancel this root, so that will be the right step. And now you have difference between two squares, so you can have x plus 1 plus root 7 and x plus 1 minus root 7 equals to 0. Now we will go to the either or step. X plus 1 plus root 7 equals to 0. Here x equals to, take everything back, so this plus 1 will be here minus 1, and the plus root 7 will be also minus root 7. And here x plus 1 minus root 7 equals to 0. So to make x by itself, take everything back. It will be x equals to, this plus 1 will be changed to minus 1, and this negative root 7 will be changed to positive root 7. So you'll have these two solutions. Okay, good. Now let's see one last example, but this one will be a little bit different because the leading coefficient is not 1 here. So let's see. So the leading coefficient is here 2. So to get rid of this 2, I want the leading coefficient to be 1. So divide everything here by 2. Divide everything by 2. This will be just x squared. Here you'll have 8 divided by 2. It will give you 4x. This one cannot be simplified, so you'll have just 3 over 2 equals to 0 over 2 will give me 0. Now we can work on the middle term, which is b. 4 divided by 2 the whole squared. What's 4 divided by 2? 2. 2 squared will give me 4. So you're going to add and subtract this number, which is 4. So now x squared plus 4x plus 3 over 2 plus 4 minus 4 equals to 0. Again the same step. Take the positive 1 inside, and this 3 over 2 the constant, take it to the negative 1. So I will group it now. X squared plus 4x plus positive 4. This will be in one bracket plus 3 over 2 minus 4 equals to what? 0. Okay. Plus 4x plus 4. Here 3 over 2 minus 4 will give you minus 5 over 2 equals to what? 0. Again this is a perfect square, so it will be x plus 2 the whole squared. Now also this one must be changed into square so that I can have a difference between two squares. So I'll do the same step like the previous one. 5 over 2. To make this squared, you have to add here a root. We need here to add a root equals to 0. So now you will have a difference between two squares. That means you can write this one as x plus 2 plus root 5 over 2 and x minus root 5 over 2 equals to what? 0. Okay, so now we will go to the step which is the either or, which is here x plus 2 plus root 5 over 2 equals to 0, or x plus 2 minus root 5 over 2 equals to 0. Here take everything to the other side, put x here, so it will be minus 2 minus root 5 over 2, and here the same thing, take everything back, so this 2 will be minus 2 and this minus will be changed to plus root 5 over 2. Here if you want to rationalize the denominator, you can rationalize the denominator by multiplying up and down. That means by multiplying here and there by root 2 over root 2, but 2 here it's enough for me, because what I care here is to show you how to use the completing the square method. Okay, good.